Hi, CTO Demon channel friends. This is CTO Demon. I'm in my cath lab at the Prince of Wales Hospital working on a beating heart model. And here I'm going to demonstrate the new ADAPT wiring. That stands for angiographic, three-dimensional, antegrade puncture technique. It's a technique specifically aimed at puncturing the distal cap into the distal true lumen. So here the model is an RCA segment 2 CTO. I have a Conquest 12-gram wire, Confianza Pro 12, with a 45-degree, 1 millimeter distal tip bend. I set on a Corsair catheter, and I have an Ikari 6 French to the RCA and retrograde injection. So at the moment, I've wired down towards the CTO, and we have LAO and RAO view. The LAO is 56 degrees, the RAO is 35 degrees. This allows a 90-degree bend between the two. So first we're going to do a retrograde injection to see where our position is. Now you can see here in the LAO view, the wire is almost dead center. Now the way we measure distance in the ADAPT wiring method is we measure the pre-tip shaft, the shaft just before the tip, and we measure the horizontal distance to the center of the target. So we imagine there's a line that comes up from the center of the target, and we see how far we are from it. And you can see from the LAO view, this is slap bang on target. From the RAO view, it's near the back of the vessel, okay, and it's far away. Now, you can see on the RAO view, so the wire tip is pointing towards the target. So the first thing we want to do is we want to classify the views. The RAO view is now the far view, and the LAO view is the near view, because the shaft is nearer. And we also want to derive the ratio. The RAO is about the edge of the vessel, the LAO is slap bang in the middle. So the ratio is very small, it's 1/10 or 1/20, okay? The near view distance over the far view distance is very small. So in the far view, we want to optimize the turn of the wire tip so that it's directly facing the target. Then on the near view, in the LAO view, we want to straighten the wire tip by very minuscule turns, okay? And this serves two purposes. One is that by very minuscule turn, we know which direction we will turn the wire tip towards the target and which way away from the target. So we don't need a 3D mental map. Now after we turn, the second advantage of this minuscule turn is straighten the wire so that the next turn will be very precise. Now in this case, because we're slap bang in the middle, we don't want to turn the wire anymore. We just want a straight tip, like so. And we want to wire in the far view, because the most erroneous view is the best view for wiring. So we're going to go to the far view, and we're going to check the wire tip is still pointing towards it, and it is. And we're going to start wiring forward, like so. Now this wire has a lot of, now it's popped forward, okay? So now we need another retrograde injection. And you can see here now, both the far view and the near view, they are about the same distance. Both in the RAO and the LAO, the wire shaft is near the edge of the cap. So they are almost equal view, which means we can use either view to wire. So in the LAO view now, we're going to turn the wire tip so that it points directly at the target. And we're going to strengthen our backup a little bit more. And in the RAO view, we're going to turn 44 degrees after we straighten. So first we need to straighten the wire tip, like so. I'm going to use Cine because it's not very clear. This is straightened. And we now know counterclockwise is the direction to go for wiring. So we want 7.5 minutes on the clock, because it's about the equal distance to turn. So we're going to turn 7.5 minutes, and then we're going to push forward. It's very tough, okay? So one of the things that we need is backup force, because without backup force, it's going to be very difficult. So I'm going to try to rotate the microcatheter in to allow. So, okay, and now we can try to puncture since we've went in. Okay, so it looks like we've punctured, and we'll check whether it's in the true lumen with a contrast injection again. And you can see we punctured in the true lumen, and we can freely wire then into the distal vessel. Oops, that's gone up to the top of the branch. So that's okay. And then we can turn the microcatheter across the lesion, like so, and switch out for a workhorse wire. So that's adapt wiring, and I hope you like the video and you can learn this adapt wiring, and it will improve your success rate in getting distal true lumen puncture. Good luck with your CTO wiring. Bye-bye.